This series will be in 3 parts. The first one, this one is more about the context, the potential prerequisites, like programming languages, for instance, and hardware choices. If you cannot use a Raspberry Pi, if you cannot buy one, you can also follow along this tutorial on a PC, ideally a Linux. You can use, for example, a bootable USB flash drive or a dual boot, but you can also do it on Windows and Mac, but it will be a bit harder. And also hardware choices, like every component you might want to buy if you want to do the fully fledged pedal. Then the second part is more about the software, how to install the basic libraries, which is Port Audio and also Jack D, and how to code the fuzz itself and the delay. Lastly, the third part will be about the hardware. How can you do to connect those components like rotary encoders or buttons to your Raspberry Pi, and more importantly, how can you get those inputs in your code to use them to control your effects. You do need some experience with programming, but not much more than understanding the very basics: variables, conditions, loops, and functions. Ideally, classes as well, but it's not required. We're gonna use C and some C++ in the third part, but you do not need to know those languages specifically. As mentioned before, the hardware in this project is pretty straightforward, as you only need a computer, which in my case is a Raspberry Pi, and some audio interface. In this part, I will give a more thorough breakdown of every component I've been using. If you don't need that, you can skip to the next part in the chapters, or just read the shopping list I wrote in the description. First, in terms of audio interface, I actually tried quite a few of them. And by quite a few, I mean many, and many of them. After buying all of AliExpress, I finally settled on one, which is a USB interface by Behringer, which is 20 euros around. And one good thing about that one is you can totally unscrew it. Here, if you want, you can even unsolder the USB and the RCA jacks and resolder those yourself and screw that directly to your enclosure, which I think is the most convenient one I found so far. Then you have the power. In that one, it is micro USB because it's a Raspberry Pi 3, and for that, I've been using this. It's not super convenient because it's really tiny, but next, for my next build with the Raspberry Pi 4, I'll be using those ones, which are pretty nice because there are slots for screws here, and you can directly build it to your enclosure. Next, for the jack, I've been simply using those, which are really nice, I guess. For USBs, I've been using this for my initial build, but those are not really convenient. Next, I thought about using things like this, but then again, those are a bit too big, and I actually think I found a better one. For buttons, I've been using simple buttons like this. You could actually use other buttons, but for my use case it's not super relevant. If you do have some Arduino test buttons like this, those are working pretty well as well. Finally, for rotary encoders, I've been using this. I don't recommend using those without the 5 in a row like that. They are less convenient to use in my taste, at least. And I'm not using any in this build, but you can use an ADC if you want to have some analog input, such as an expression pedal. If you are interested in that, I could make another video for expression pedal. And lastly, if you don't use any Raspberry Pi, if you are just doing it on a computer, but you still want to have some user input, you could use some flavor or of Arduino board to get the user input. I'm quickly gonna show you how you can do to configure your Pi to code and access it remotely. For my example, I'm gonna use a VNC server because for me it's easier to record the video. But let's just imagine you just got yourself a Raspberry Pi, you plugged in your external screen and keyboard and mouse, and now what do you do? Oh, and as a side note, if you don't have any external screen, keyboard and mouse, it's a bit harder to configure. I will give you a link in the video description for how to do it. But for now, let's focus on the task. we need to enable the VNC server, which is remote viewing like that, and a SSH server, which is a remote shell. A shell is a command line like that. First, you open a terminal and you type. Now locate the interfacing options, SSH, then click yes. Good, SSH is enabled. Interfacing options again, VNC, and yes, perfect, VNC is enabled. Now one thing to note, before normally you didn't have this logo and now it should have appeared in front of you. When you click on it, you have your IP. Remember that one. Technically, you could actually program from your VNC because it's normal, you have code editors, you have everything, but it will be a bit harder and, well, less convenient. So what we are going to do is use an IDE, a code editor. For this tutorial, I picked Visual Studio Code because it's pretty convenient and easy to use, and that's the one I'm going to show. But you can use as well Sublime Text, Atom, or, well, many others. But first, to have some SSH remote connection on Visual Studio Code, we need to follow a few steps. Once again, I'm gonna give you the link in the video description. First, you need to install OpenSSH. It will be different depending on your OS. Maybe this for Windows. Then install Visual Studio Code. Then again, the extension. And now you finally have access to this logo. And indeed, when I look in my Visual Studio Code, I do have this logo. So if you follow the step, you should have it now. Click on it, connect to host, type your username, which is by default Pi on your Raspberry Pi, then your IP. It will prompt you for a password. Put the password you inserted when you first started your Raspberry Pi. Okay, now you are logged in. You can see it on the bottom left corner. But to open a folder, just click here and open folder. By default, it's pointing your home folder. You might want to change that later, but for now, it's good. Perfect. We view, okay, we are viewing every files open in your home directory, and for instance, port audio, example, and PA fuzz. Exactly what we are gonna use in the next part.